Okay, we're back again, and we're going on with video number 8 this time on using a magnetic drill and where we position holes. Okay, so we're going to drill this beam. I've already just drilled the other one. I'm going to drill this and the importance of where to position the holes. Now, if you're using a magnetic drill, this little one, okay, where we want the drill hole is a little bit to the front of the web. There's the web, we call that the web. They're the flanges. Okay, it's top and bottom flange and the web. Now, if you get the hole too close to the web, to the back of the steel, you can't tighten up the nut. You can't get in there with a spanner. So we try and keep the holes to the front. So, you know, reasonable centre, but still to the front of the steel, so we have no trouble getting spanners in to do up the bolts. So what we do is use a drill. That's how I teach people. We have one side of the drill is with the flange. Now, if it's a smaller piece of steel, which we get quite a bit, okay, then I'd have the this side of the drill flush with the back of the back flange, and the drill will be that side because the flanges would be a lot smaller. So so we'd have it flush with the web. Getting terminology mixed up. Okay, so we want to have the hole reasonably centre, but we want it away from the web. So it's top and bottom flange we're drilling. So that's where we're at. We got that. Position the drill. We've turned the drill on so the magnet has it. Okay, it's a magnetic drill. So it stays there. We use them upside down on this side. Of course, when you're doing that, you want to have something to tie it on or to be able to hold onto it while you do the work. Because in case electricity goes, this thing drops like a rock. It's quite heavy. It's a good what, 8 kilos. So yeah, you want to make sure you're holding onto it while you're drilling. Where down flat, there's no problem. It can't fall any lower than the top flange of the steel. So she sits there nicely. And of course, with a bit of noise. Now we do have in the top here, hard to see, but it's in there. We have a white liquid. It's a white fluid, which is water-based oil. Okay, to help cool the tip, because the drills get quite hot. And of course, to keep them and make them last, we cool them down with some lift fluid, oily fluid, and here we go. Quite loud. Those with sensitive ears, you might want to use earmuffs. And there she goes, showing you how it's done. Now, of course, we also have a protective barrier if you want to use it. It slides down over the drill to stop all the bits and pieces of steel from going everywhere. Now, as you see, that steel comes up in, it's like steel wool. Virtually how they make steel wool. Okay, and just quite a bit there. Now you never, okay, we'll show that to you. Okay, with a magnetic drill, of course, it doesn't move. The drill bit is hollow. It has a little pin in here because it pushes up, lets the water through. And here we have, it's like a steel wool. It really is. Now the weird, wonderful, or shouldn't say weird, wonderful, is the part that gets quite scary if you don't know what you're doing is, okay, this is what this shield is for, is to stop your hands from getting anywhere near that drill. Right, because as you do that and wraps up that steel wool comes out. If that guard's up, well, we operate because we're going so fast. If you're holding this drill bit here, this drill handle here, you've got your fingers right next to this. Now that steel wool is traveling quite fast, and it grabs anything that's in the way. So if your finger's in the way and a bit of that steel wool grabs your finger, there's a good chance you may lose a finger. Because this drill will not slow down. Even once you turn it off, it takes a little bit to wind down. And if that steel wire grabs your finger, say goodbye to your finger. Because it's razor sharp. It'll just chop straight through it. Okay, so little safety features. Once again, if you like wearing gloves, okay, that may help for a second or two. But if it grabs your finger, glove or not, it's going to take it off. Okay, so just don't put your fingers near it. When we operate the drill, we don't have our fingers We don't put our fingers on the one closest to the drill bit. All right? We just don't do it. That's how I teach people. We try and stay safe. Because some of our drills don't have guards. Okay, and the same with the drill, the battery drill, or other electric drills. You do not go near that wire that's spinning, because yes, it's nasty stuff. All right, so here we go again. On with the drill. Cut. Pull it on a few times so I get some fluid into the steel, because that steel is a little over half an inch thick. Just before it gets to the end, pull up, then, don't know if you saw it, but there it is there. Yeah, can you see that? That's it there. That's the centre that popped out. Okay, this drill is hollow. It cuts around the outside of the hole and pushes the centre out. And that's how it's done. And then we've marked, now here in Brisbane, our standard building code says that we're supposed to have a hole roughly every 600 mil, every 2 feet. All right, or thereabouts. It was back in the 20 years ago, it was every 1200, every 4 feet. Then it went to 900, now to 600. So, and if you go up into the cyclone areas or hurricane areas, it gets even closer again. It gets down to 450, I think it is, or even 300. 1 foot every bolt. Okay, to tie it all down so it doesn't go anywhere. These are all part of the building codes, the building standards that you work with. And when you get build a house and you're getting all this done, of course it's all designed by architects and engineers. So you go with the engineering to tell you where you're supposed to put your holes. All right, and how many. And it doesn't hurt if you put a few more. Never put less. Okay, you're trying to do high quality work, that means you put more than what the engineer requests. Go bigger sizes, what the engineer requests. You know, just see what you're doing. If it needs more, if you feel it needs a stronger piece of steel, put a stronger piece of steel in. We have the same here. We have this one. This one the engineer has a 230. Now, yes, a 230 may have done that, but I wasn't happy because of that big span there. I wasn't happy with the 230, so I put a 250 in, which is almost double the weight. Okay, now the engineer has on the top beam, which is the one that goes from that one there across to this one with no post in between. Here we've got a post in between, and we've got a 230, which I've made a 250. And here he's got on the engineering a 250 to go from there to there, which is 8 metres, 8 metre span all by itself, and he's got to hold the roof up. Now, you know, I'm not happy with that. So we're going to go back to the engineer and see what he thinks. I prefer a 380 PFC in there, but we'll see what we come up with. Because 8 metre span by itself, without it sagging, and without pulling those posts around, that's a tall ask. Especially when you get in the middle, it's going to bounce up and down 1.5 inches with the 250. And you just don't want that. Not by the time you get all that roof weight on there. So that's what we're doing there. So yeah, back to the steel here. So that's what we're doing. Finishing these holes, I've got to drill all that side, then I roll it over and do the other side. Okay? And we stay, my first hole is, I came in 150. The engineer usually specifies roughly 100 to 150. Reason why is because on this side, where it welds onto this steel, there's another piece of timber, or maybe even 2 pieces of timber here, that go up the inside. And of course you still want to be able to get to the bolt, or you don't want the bolt underneath the joist or underneath the studs, so you come in a bit. Okay, you'll work it out. Anyway, that's where we're going to leave it. We'll get back with another video yet. Okay, thanks for joining us, thanks for viewing, hope it's helpful, and talk to you again soon. Hit those buttons. Love yous. Bye.